Good day, everyone. We're going to go over section 13.3. We're going to run through the hypothesis test for paired T. So remember, we're comparing two population means, but the samples are dependent. When they're dependent, we're running a paired T test. And, um, and so we already ran through the confidence interval. So let's go ahead and run through the hypothesis test for this type of scenario. So remember the problem where we had the pharmaceutical company and they created a new pill to help lower cholesterol? All right. Okay. Well, let's see if we can run through this. All right. Example, but on the hypothesis side of things. All right. So here, remember, we're creating the differences. That's our new random variable. And so we got the before minus the after. And 42 was the first person, 27 was the second, and -2 was the third, and then we had a bunch of positives for everybody else. So remember, the D's are the new random variable. And please do not skip this step. This step right here explains a lot what we put into the alternative hypothesis. I'll explain a little later, but remember when I told you to define what a negative D and a positive D means? Well, okay, let's do that. So a negative D meant the medication definitely wasn't working. Maybe it was even hurting in some way, shape, or form. And positive D means pill was effective in lowering cholesterol. Okay, now keep that in mind because that's going to play a huge, huge part um, with figuring out what to put into the alternative hypothesis. All right, well, let's remind you of some of the background stuff um, that, I went through this and said, okay, that means if mu sub d is greater than 0, that would show that on average the pill was working. And so remember, mu sub d is the parameter, and it is equal to mu1 minus mu2. All right, and there I stated about the cholesterol. If it was greater than 0, there we go. All right, and so that's giving you a hint what's going to go into the alternative is right there. All right, again, what's the corresponding statistic? That's D bar. All right, that turned out to be 20.8. And so, steps in conducting a paired t-test, here's the thing, is that it's exactly the same test as just running a t-test because we took everything and shoved it down to one random variable, looking at just one mean, and there you go. It's running the t-test. It's just that instead of having a random variable of x, we have d's. So step one, state the null and the alternative, right? So here, what we're going to do is we're going to state mu sub d is equal to 0. And if you think about it, what that's stating is that mu1 is equal to mu2. There's no difference between the two, okay? There's no difference. Nothing's there. And then we have to decide if mu sub d is either going to be less than, greater than, or not equal to. And that just depends on the problem. And remember, that has everything to do with the positive d's and negative d's. 2, verify the conditions. So we need a random sample or experiment, or either then we also need either the d's are normal or n being greater than or equal to 30 for the central limit there. So if we had either case, that means that the sampling distribution of d bar would be a t distribution, approximately normal, right? Step 3, calculate the test stat. Here's our test stat. It would be d bar instead of x bar. We'll just put mu sub d. Remember, we had mu sub 0, but where is that coming from? Mu sub d. Where do you think that's coming from? That's still coming from the null hypothesis. I can't in PowerPoint, I can't do two subscripts. I can't do a subscript of mu and a subscript of d. And so, but I hope you get the idea that this guy right here is always coming from the null hypothesis. Okay, because we take d bar minus whatever's in the null. All right, and then divide by the standard error. Remember the standard deviation, the d's divide by the square root of n. Okay, and the standard deviation of d's will be given to you in the problem, just like with the confidence interval. Then we calculate the p-value, and I showed you how to do that in StatCrunch just in the last section, because we're going to because it's remember the test stat is in terms of t. Okay, and remember got degrees of freedom of n minus 1. So when you do your homework for this section, stack crunch for the p-value. Then we're going to compare the p-value to alpha and state the conclusion in terms of the problem. So it's the same steps. Okay. So instead of constructing the confidence interval, we're going to test at the 5% significance level if the new medication is effective in lowering cholesterol. Now, here's the thing: is that once this is where students get a little confused. Okay, they see that, oh, we're testing if it lowers cholesterol. However, what's actually showing that the cholesterol is being lowered? It's because the D's are actually greater than 0. That's when that happens, is when the D's are greater than 0. And so you got to be careful here, because you're tempted, because it says in lowering cholesterol, okay, that you want to put less than 0. However, it's actually what? Greater than 0. Okay, because a positive D, this is where it comes into play. Positive D, excuse me, positive D means that the pill was effective. And so if mu sub D is greater than 0, it's effective on average for everybody, right? So that's where you got to be careful. And so if you don't skip the step of defining a negative D and a positive D, you're good. What are the conditions? Well, random sample. And then I told you that a lot of times we're not going to make n to be greater than or equal to 30, especially if we're going to have you calculate some of the stuff. And so in the problem, I would have to state that the differences are normal. Let's go ahead and assume that. And that'll make the sampling distribution of d bar a t-distribution. Calculate the test stat, assuming the standard deviation of the d's, 12.5. So I put that into formula, and we come out with a whopping 6.44. Very large test stat in terms of the t. So our d bar is 6.44 standard errors above the value in the null. That's fairly significant, right? And so what's next? We got to calculate our p-value. We got to go to StatCrunch for that guy, right? And so let's see, we have 6.44 and 14 degrees of freedom, right? 6.44 and 14 degrees of freedom. All right, so let's get out of this. And let's get into StatCrunch. So remember, you go to Stat, Calculators, T. Okay. And as I recall, what I just said was 14 degrees of freedom. 6.44. We have a rate tail test. And there's our p-value. It's 0.000000774. It's really small. Okay. We expected that to be a really small test, p-value, because the test stat is so high. And so I translated it over onto my slide here. Okay. So we calculated the p-value. And I'm just waiting for my computer to catch up here. Here we go. Remember, our degrees of freedom was 14. There's our p-value. Okay. So versus any reasonable alpha, I could care less where you set alpha. Remember, alpha is probably the lowest it's going to be is 1%. So any reasonable alpha, we're going to reject the null, right? So, and we have really, really strong evidence now at the 5% significance level. New medication on average will be effective in lowering cholesterol for all people. All right. Now, we shouldn't be surprised about this, because when we ran through the confidence interval, so in running through the confidence interval before, we came up with a interval from 13.88 to 27.72. It was what? It was entirely positive. Okay. And so it was certainly greater than 0. Okay. It was certainly greater than 0. And so, so that just confirms everything when we ran through the hypothesis test. We got consistent results. All right. And here's the second question. Remember, this was the one where my students had an opportunity to come in and look at their exam, their first exam, and then do a retake. Okay. And so I looked at the students who came in. I just made the numbers up, by the way. Who looked, so they took the retake without looking at their first exam, and so wanted to see if there was a significant difference here. And so we're going to test at the 5% significance level. All right. If the test score is increased. Okay, so now let's take a look here. Here's our differences. I started filling them in. So I got a -2 for the first one, 4 for the second one, 0 for the third one. So what did a -2 mean? A -2 actually meant what? That the that from their first attempt to the second attempt, their score increased. Negative means increased. All right, and so positive D, student did worse with the second attempt. So notice with the second person, they went from 54 down to 50. And then if you had 0, there was no change. Okay. So if mu sub D is less than 0, on average, students did better with the second attempt. Mu sub D was greater than 0, on average, students did better with the first attempt. And you get all this because of defining the negative D's and positive D's. Okay. D bar turned out to be a negative 1.75. So what are we going to state the null and the alternative hypotheses as? Well, we're going to state it as mu sub D is equal to 0 for the null. The alternative, mu sub D, be careful, even though it says test at the 5% significance level, okay, or at an alpha of 5%, if the mean test score increased, everybody wants to go, oh, increased, put a greater than sign. No, okay. It's a less than sign here, so you got to be careful. Got to be careful. Verify conditions. So we got our random sample that created these random pairings. Okay, and again, I would have to indicate that the D's are normal because CLT still doesn't apply here. Okay. Calculate the test stat, assuming that the standard deviation of the D's is 4.267. Threw that into the formula. I got a negative 1.42. That's telling us that our D bar was a negative was 1.42 standard errors below the value in the null hypothesis. And what was the value in the null? 0, meaning mu1 is equal to mu2. I'll assume that you can look this up in StatCrunch. The degrees of freedom turned out to be 11. And when I looked it up, it turned out to be 0.0917 for the p-value. All right, well, at an alpha of 5%, we're going to say do not reject the null. All right, we do not have strong evidence that the alternative was correct, meaning that we don't have strong evidence that on average there was an increase for all the students. Okay, and so they probably should have looked at their first exam, right? Now, let's take a look at the confidence interval. The confidence interval gave us what? It gave us a negative 4.46 to 0.96. So notice, it could have gotten better, could have gotten worse, or no change because we have negatives in there, we have positives in there, and we cross the value of 0. And there you go. So do we know which one it is? No. All right. And so this should have been no surprise that we said do not reject the null hypothesis, because what was the value in the null? 0. Is that a possibility? Yes, that's a possibility. And so when it's a possibility, we do not reject it, and pretty much everything's still in play. That means mu sub D could be less than 0, greater than 0, or equal to 0. We don't know which one it is. All right. And that's it. That's it. So it's pretty simple. Once you know the t-test, and we already did the confidence intervals, and doing the paired t-test hypothesis test-wise, pretty straightforward then. All right. Thank you for your time.